Okay, so what would be the derivative of the sine inverse of x? Um, let's see. What do we got here? All right. So we have y is equal to sine inverse of x. Let's see here. Before we take the derivative, why don't we kind of rewrite this and do the rewrite it by taking the sine of both sides. So we're taking the sine of both sides. So we're going to have here on the left side, sine of y is going to equal to. These undo each other. So sine y equals x now. Because sine and sine inverse cancel. So we're going to have x. Okay. Now we're going to take the derivative. Yeah, let's take the derivative. Okay, so now we're going to take the derivative. D dx of it. So what's the derivative of sine y? What's the derivative of sine? Cosine. So we're going to say what? Cosine y times what? Dy dx. Yes. And that is going to equal to the derivative of x is 1. Okay. So now we got the dy dx by itself. Oh, no, not by itself. We can go ahead and put it by itself by getting rid of this cosine y. So how do I get rid of this cosine y? Divide by cosine y. Divided by cosine y. And now we got dy dx by itself. So dy dx is going to equal to 1 over cosine y. Okay. So now what is this 1 over cosine y? What is this? Dy dx 1 over cosine y. Can we make a triangle out of this? Let's do a triangle just for this cosine y part thing here, down here, cosine y. Let's make a triangle. A right triangle. And I'm saying, what is cosine y? Cosine y equal to? Well, what's the definition of cosine? What is the definition of cosine? Cosine is what? All right. Let's put this y. This y is a angle. Theta is theta here. Let's put it here. Y. So if we're here and we're saying cosine y, we're going to label something to be x. Let's say x is what? Let's say this is x. What else can we say? What else can we say about this? Let's see here. Dy dx 1 over cosine y. Cosine y, let me see. We got a 1 here. Cosine y. What can we do here? Anybody? I'm already labeling this x. Why am I labeling x? Because y is an angle for sure, no? Because cosine y is an angle. And you said it was adjacent over what? Cosine is adjacent over what? Hypotenuse. If we say this is a unit circle, if we say that this is a unit circle, then this would be 1, no? What else? What else can we do here? What can we do here? anything else here. We're saying x, oh, back over here, we're saying that x equals sine y. X equals sine y. Ah, I put it wrong. Because if from this statement I'm saying sine y equal to x, where y is this, then x, because the definition here, going back to here, sine y equals x, I'm saying here. Then what's the definition of sine? What is sine? Opposite over hypotenuse. So I put the x in the wrong place, because from this statement I'm saying that sine y is going to be x over 1. Ah, okay, so we got to go back to this statement here. This is wrong, then this got to be x. Yes, that makes sense, because sine y is opposite, and I'm telling that's x over 1. So that is 1. Yes, yes, so far this is good. So cosine y. Hypotenuse is 1. This is 1. Because the hypotenuse is 1. What is this though then? What is this? How can we figure out what this is? Based off of what we know here. Can we do Pythagorean theorem here? Yes or no? Yes? Wouldn't this be what? This is C. You can call this A, and this is B. And B is the question mark, what we're looking for. So we can say what? A squared plus B squared equals C squared. So we're going to say what? 1 squared equals A squared is X squared. And then plus the question mark is what we're trying to look for. Squared. Yes? Making sense so far, no? So we got 1 squared is 1 equals x squared plus the question mark squared, that is b, no? But I'll leave it as question mark. And then we can subtract it, and we're going to get 1 minus x squared equals question mark squared. And then we can square root it, and then we're going to get the question mark is square root of 1 minus x squared. Yes. So the adjacent, which is right here, b, is square root of 1 minus x squared over 1, which is square root of 1 minus x squared only. And now we can substitute that cosine y is this. And we can plug it in here, and we have solved it. 1 over square root of 1 minus x squared is the derivative of sine inverse. All right. So how many of these do you really need to know? You do need to know this one for the AP exam. So you do need to memorize this one. dy dx is 1 over square root of 1 minus x squared. Sine inverse is this. In the same manner, we can get the derivative of cosine inverse, tangent inverse, and all these other inverse trig functions. But that's enough. I think we've had enough with that one. So what are the other ones you need to memorize? Derivative of inverse trig functions. The derivative of sine inverse x is 1 over square root of 1 minus x squared. Yes. The derivative of cosine inverse x is going to be what, do you think? What do you think? I'm going to just guess, everybody. I'm going to guess that there's just going to be a negative right in front of it. And then let's just say, let me see if I'm right, because I'm not good at memorizing. Oh, yes, it is. So the derivative of cosine inverse of x, just put a negative in front of what the sine inverse was. Okay, good. Absolutely 100% you need to memorize the derivative of tangent inverse. That's for sure. This one comes up a lot in the second semester. Tangent inverse, the derivative of tangent inverse of x is going to be 1 over x squared plus 1, or you can just say 1 over 1 plus x squared. And the derivative of cotangent inverse of x is going to be, what do you think? What do you think? Same thing but negative. Yes, yes. Negative 1 over 1 plus x squared. I could tell you that these are the only ones maybe that you would need, and because they're not very sure again about what the derivative of secant inverse of x is, because some books have it as this with an absolute and the other books have it without an absolute. So you don't necessarily have to remember these two here at the end. Write them down if you want, but you don't need to really. It's not gonna stop you from getting a 5 if you don't know these ones too here. But these ones for sure you want to know these ones here. That is it. Let's go ahead and apply. Alright, ready? Let's do some problems now. Alright, let's go. Find the derivative of the function. Simplify where possible. So what is what's the derivative of tangent inverse of x? 1 over 1 plus x squared? Yep. And then what's the derivative of this? Well, that would be what? Plus 2 over 2 square root of x. That 2 and 2 cancel out. So it will be 1 plus x squared plus 1 over square root of x. So you're saying, like, to what level, how much do you need to simplify? I think this is enough, I think. Let's see. Yeah. All right. So this is enough. Oh, there we go. Chain rule now. Chain rule with that. I'm going to continue on using my little machines here. So what's F and what's G here? F and G. What's F? X squared? Yeah, x squared. And G gotta be then tangent inverse of x. So the derivative of x squared is 2x. Evaluated at this, so it'll be 2 tangent inverse of x. And the derivative of this is 1 over 1 plus x squared. And you put it right here in the back. 1 over 1 plus x squared. Yeah, that should be good. All right. Yeah, this is good enough right here, but depending on what you get on a multiple choice, they might simplify it a little more like that right there. All right, next. Number 3. This also is a chain rule, but we can just do it quickly. F is the outer, would be sine inverse, and the inner would be 2x plus 1. So y prime what was the derivative of sine inverse? That's the one we did. 1 over what? What was it? 1 over what? Square root of what? Was it 1 minus this thing, no? This thing times the derivative of that thing is 2. We can simplify more this inside here. Y prime equals 1 over square root. Distribute that 1 here. So it'll be 1 minus 2x. And then put a 2 on top. Times 2 here. So y prime equals 2 over square root of square root of negative 2x. What happened? What?
2x plus 1 is square root of 1 minus.
Oh, squared? Is it squared? So would this be like simplified, or do we need to simplify some more? Yeah, I guess we got to simplify some more, no? That's a lot of simplifying. I don't want to be, that's enough. But you would, okay, let's go. 1 over square root, you got what? 1 minus, so you got 2x plus 1 times 2x plus 1. If we have to do this simplifying, 4x squared plus 4x plus 1. And yes, it is. You're going to do 1 minus 4x squared minus 4x minus 1. This is 2. So you're going to get 2 over square root. Want to cancel out, and you can factor out, factor out of 4. So because you're going to have negative 4x squared minus 4x, you could factor out of 4. So you're going to get 2 over square root 4, and then leave the negative x squared minus x. Because I don't. Yeah, because you could factor out a 4 here. Yeah, let's do that. Just the 4, because you could take square root of it. So then you can go ahead and do 2 over square root of 4 is 2 square root of negative x squared minus x. And these cancel out, so you will get 1 over yeah, it's just a bunch of algebra that you got to do there at the end, just in case on a multiple choice they do go all the way to that. Minus x squared, huh? All right, 4. So another, I mean, what do you guys want to do here? What do you see? Do you see a quotient rule? Or do you see a chain rule? We can do it either way. Let's do a chain rule. Let's do chain. So what is F and what's G then? If we do chain, what's F? 1 over X. I don't know. Maybe the other one is better. I don't know. And then G gotta be what? Sine inverse. So then, what's the derivative of 1 over X? Did we do that? What's the derivative of 1 over X? Yeah. Maybe we should do the quotient better. But anyways, let's go. So what's the derivative of 1 over X? That'll be X to the negative 1. The derivative of X to the negative 1, it'll be negative 1 over X squared. So this is negative 1 over X squared. Evaluate it here. So it's going to be negative 1 over sine inverse of X squared. The whole thing squared, if you want to write it like that, it's fine. That should be good. And then the derivative of this is what? What did we say it was? I didn't. 1 over what? 1 over square root of 1 minus what? X squared. Yep. You know what? This is good. Then times it by 1. So it'll be 1 over square root of 1 minus X squared. Yeah, we could have done the quotient rule on this too. Yeah. All right, let's go. Number 5. On that test you guys took for chapter 2, a lot of you guys messed up on the front page because you don't know how to extract, I guess, sometimes the function from the limit definition. This is one of the limit definitions of the derivative right here. But they're already telling you what f of x is, though. So they're already telling you that's what f of x is, the arc sine of x. So the function, you don't have to extract anything from there because they're already telling you is arc sine of x, which arc sine of x is sine inverse of x, evaluated at x, or not x, because they use a equal at a point, so at a equal what? 1/2. So just take the derivative of f of x, f prime of x. F prime of x is, now I can't mess it up, something like 1 over 1 minus x squared. And f prime at 1/2 will be 1 over square root of 1 minus 1/2 squared. Which is going to give you 1 over square root of 1 minus 1/4, which is 1 over square root of 3/4, which is going to be, the square root of 4 is 2, so 1 over square root of 3 over 2, so it'll be 2 over root 3. I guess let's do this, finish with this, number 6. Find the equation of the tangent line to the curve at the given point. X minus a negative, so it's plus root 3 over 10. So we need to get these ones here. We need to get y prime evaluated there. So y prime equals y prime equals what? 1 over square root 1 minus what? We said x squared. Yes? Where x is going to be what? 5x, no? And then the derivative of that is going to be what? The derivative of that is 5, no? So y prime at what? Y prime at negative root 3 over 10 is going to equal to 5 over square root 1 minus, in parentheses, 5 times this thing here, negative root 3 over 10 squared double parentheses, another parenthesis, double parentheses. All right, 5 over 1 minus 5 goes into 10 two times, so it'll be negative root 3 over 2 squared. It's going to be now 5 over square root 1 minus negative square root 3 squared is 3, and then 2 squared, this should be 4, and then we have what? 5 over, what's 1 minus 3/4? Is that 1/4? Square root of 1/4? And the square root of 1/4 is what? Is that 1/2? 1/2? So what, is it 10? Is it 10? Yeah? Oh no? Jacob, is it 10? Yes? Is it 10? Or no? All right, say it's 10. Oh no. Hold on. Yeah. Okay. Let's see. Okay, it's 10. I don't know. This thing is different or whatever. All right. So now, how do we find the white? The white part here. plug it into this here, no? So y is going to equal to sine inverse of 5 times x is root 3 over 10. So then y is going to equal to sine inverse of root 3 over 2. Okay, here's another one review of algebra and pre-calculus. For sine inverse, you find solutions for sine. Okay, sine inverse of x or whatever. You find solutions on the right side of the y-axis from negative pi by 2 to pi by 2. And for cosine inverse of x, you find solutions on the top half from 0 to pi. It has to be unique in its. So the solution for sine inverse is going to be either, it cannot be, because this is positive. Root 3 over 2 is positive, and if I take the sine of something, if I draw a triangle here, then it's going to be negative over this. It can't be. So the solution is going to be found in the first quadrant. So it's going to be found right here. So what is root 3? Sine is opposite. So we're looking for the angle. So what is this? In order to root 3, this is opposite over 2. So what did I say about that? What is this angle going to be here? It's either 30, 60, 30 or 60. Opposite of 30. 30, opposite of 30 is 31. It's not it. 60, opposite of 60, 3, radical 3. This is 60 degrees. And 60 degrees is going to be, what is 60 degrees in radians? Pi by 3? Pi by 3? Pi by 3. So that's just pi by 3. So this should be pi by 3. Hold on here a second. Were you guys, let me see. It was negative? And I put positive? When I did it, look, when I plug in, it should be plugged in negative this, and it would have been negative. I wrote down positive. So it would have been found either that one or this one. It was negative. I didn't put the negative here. I forgot to put the negative. So it turned out to be what? Sine inverse of what? Negative root 3 over 2, no? Yes? And so it wouldn't have been this one, it would have been this one. Yes, sir? Because when it comes to like sine, it has to be unique in its solution, because the sine inverse, it could have infinite amount. And to cut the solutions for sine will be found on this. And if you would have said, what is the, say for example, cosine inverse of root 3 over 2? Say for example this, no? This, cosine inverse of root 3 over 2, it would either be here or here, one of these. And since it's positive root 3 over 2, it would be this one. If it would have been a negative root 3 over 2, cosine inverse of negative root 3 over 2, it would be the one here. Because cosine is negative right here, x is cosine negative. That's it. We're done for today.